Well, this video is for Math 112, Trigonometry, and this is the follow-up section on applications, section 1.5. So there's the difference between 1.4 and 1.5 is the type of problem. If you remember the problem in section 1.4 where we were shining the spotlights up at the cloud, we had to create this system of equations to allow us to find the value that we were interested in. So these problems in section 1.5 are very much like that. So the trigonometry is the same, but the algebra is a little bit different, or a little bit trickier. So let's take a look at problem 2. This is a good example of this idea. We've got these two triangles, and this comes up frequently when people are taking measurements. 52.5 here, and we want to find this value of h, and we know that this distance here is 168 feet. So frequently what people do is like, for a mountain, let's say, because a mountain, you know, the height of it is really not accessible, right? It's in the interior here. And so frequently what people do is they come to it, they find a good spot where they can take a measurement of an angle to the top of the mountain, and then they back up a certain known distance, and they take another measurement to the top of the mountain. So that's where this diagram is coming from. So you've got the two angles along with the distance between where those angles are measured, and that'll allow you to calculate that h value, which is what we're interested in. Okay, so how do we go about doing this? Is to introduce two variables. We've got the h here, that's what we want to solve for. Let's call that value x, that distance there, x. That says that the tangent of 52.5 degrees is going to be h over x, and the tangent of 41.2 degrees is going to be h over x plus 168, right? This whole distance right here. If we look at that larger triangle, we've got that 41.2 degrees, h here, and then this distance right here, the adjacent side, is x plus 168. Okay, so there's our two equations. So what we'll do is isolate the h in this equation, and so that'll give us h is equal to x times the tangent of 52.5 degrees, and then we'll come and plug that right in here, okay? So then we'll have the tangent of 41.2 degrees is equal to x tangent 52.5 divided by x plus 168. Okay, so there's our setup now. We've just got this single variable x that we're going to solve for. And so to do that, we're going to multiply on both sides by x plus 168. And so then we'll get x times the tangent of 41.2 degrees, and then plus 168 times the tangent of 41.2 degrees, and over here, x times the tangent of 52.5 degrees. So if you remember in the previous section 1.4, I talked about how you can hold on to these values and generate an exact expression for the solution, and maybe I'll come back and do that again at the end, but at this point I'm going to approximate all of these values here. And so let's see, the tangent, first let's make sure I'm in degrees, yep. So the tangent of 41.2 is going to be 0.8754, we'll call it. 8754x, and then 168 times the tangent of 41.2 is going to be 147.07, And then over here, the tangent of 52.5 degrees is 1.3032x. So let's, on both sides, subtract 0.8754x. Those will cancel out, 147.07. Over here, what are we going to get? 8, 7, 2, 4. It looks like 12, 13, 10, and 13 again. Okay, so divide on both sides by 0.4278. So 147.07 divided by 0.4278. And we get x is approximately 343.789. And so then I'll take that and multiply it by the tangent, let's see, times the tangent of 52.5, and that'll give us a height. So we'll take our x, 343.789 times the tangent of 52.5 degrees, and that gives us a value for h of about 448 feet. Okay. Let's see. So, what if we come back to here at this point? The process is the same. We would subtract this on both sides. Okay. So let's see. X times the tangent 41.2. And then 168 times the tangent 41.2, x times the tangent 52.5, right? Okay, so we subtract this on both sides. 168 tan 41.2 degrees. Here, factor out the x and we'll have tangent 52.5 minus tangent 41.2. And again, this I go over in more detail in Math 111 when we're solving equations involving logarithms. Then I talk about this in some detail in that section. And then the last thing we need to do is to divide on both sides by this tangent 52.5 minus tangent 41.2. And this is in the text, this is in the trigonometry textbook as well. I give an example in section 1.5 going over this process right here. Okay, and so there's that 168 tangent 41.2, that's this number right here, 147.07, and this 0.4278, that's the difference between tangent 52.5 and tangent 41.2. All right, so I'm going to go through this process on the rest of the problems and kind of skip over finding that exact value. It's a good skill to have, to know how to do that. But for this process, I think the approximation is good enough. But it's important to make good approximations. You notice that I took 4 decimal places for those tangent values, and that is important. Okay, so let's see here. Problem 4. A hot air balloon is flying above a straight road. Okay, well, there's the balloon. In order to estimate their altitude, the people in the balloon measure the angles of depression to 2 consecutive mile markers. All right, well, let's say there's 1 mile marker here and 1 mile marker here. So let's see here. The angle to the closer marker is 17 degrees, so that's this whole thing right here. And then to the second one, the farthest one, is 13 degrees. So that means that this angle in here is 13 degrees, and this angle in here is 17 degrees, and there's the height of the balloon. Okay, so what's missing here is this distance right here, but these are mile markers, and so they are 5,280 feet apart. If you just used 1 mile on this, that's fine too. But now that we've got that set up, then we're going to go through the same process that we just did in the last problem. Call this x, and then we'll say the tangent of 17 degrees is h over x, and the tangent of 13 degrees is h over x plus 5,280. If I used 1 here, then that would give us the elevation in miles rather than feet. Okay? I don't think the problem tells us. It just says at what altitude is the balloon flying. So I'm going to do this in feet rather than miles. But if you solve it in miles, then that's fine, unless the problem specifically asks you to do it in feet. All right, so let's get the h by itself up here, and then take that x tan of 17 degrees and plug it in there. X plus 5,280, okay? And so that's the first step, first step is to write those 2 equations. Second step is to isolate the h, and then plug this x tangent 17 degrees in for h in the second equation. Now that I've done that, I'm going to multiply on both sides by x plus 5,280. And so this will be x tangent 13 degrees plus 5,280 tangent 13 degrees. So let's do some approximating. Okay, so tangent 13 degrees, 23087. And then 5,280 times the tangent of 13 degrees, 1,218.98. And then the tangent of 17 degrees, 0.30573. Okay, so same thing we did in that last problem. Subtract this on both sides. We'll leave that 1218.98 where it is. Let's see, 30573 minus 23087. And we get 0.07486. Okay, there we go. So now we just have to divide on both sides. 0.07486. So 1218.98 divided by 0.07486. And we get 16,283.46 feet. So that is several miles. So if I divide that by 5,280, that's about 3 miles. Right. So that was problem 4. Let's take a look at problem 6. Okay, so problem 6, angle of elevation from a point on the ground to the top of a pyramid. So there's the pyramid, let's say, and we take our angle of elevation, and that turns out to be 35 degrees, 35 minutes. And then 135 feet further back, you take a new angle of elevation, and that is 21 degrees, 10 minutes. And we know that this is 135 feet. So this is the scenario that I was talking about a few minutes ago, where this is going to be our H, this will be the X. And so we'll start out, let's see, tangent 35, this is 0.5 degrees, right? That 30 minutes is a half a degree, and that'll be H over X. And then the second one, 21.16 repeating degrees, that's going to be H over X plus 135. You do that 10 over 60, and that'll be 1/6, which is 0.16 repeating. Okay, from there the process is the same. We're going to have H is X times the tangent of 35.5 degrees. And then we'll take this and plug it in here. X tan 35.5 over X plus 135. And then we'll multiply on both sides by X plus 135. Those cancel out. And here we get X times the tangent of 21.16 repeating plus 135 times the tangent 21.16 repeating. And then over here, X times the tangent 35.5 degrees. And then we'll make a substitution. Okay, so tangent 21.16, and I'm just going to hit that 6 a bunch of different times. You know, get at least 6 or 7 of them in there, and then we'll get a good approximation. 0.3872 times X, and then 135 times the tangent 21.16 repeating, and that's 52.27. And then over here, tangent 35.5, 7133x. So then subtract 0.3872x on both sides. Over here, what are we going to get? 1, 6, 2, 3, right? 13, 11, and 7. Okay, so then we got to divide on both sides by 0.3261. So what do we get? 52.27 divided by 0.3261, 160.3 feet. And then we multiply times the tangent of 35.5, and that gives us 114. H is 160.3 times the tangent of 35.5 degrees, and that's approximately 114.3 feet tall. So my drawing is not drawn to scale, right? If this is 135 feet, then our pyramid shouldn't really be any larger than that. And I think some of that is in these angles too. This angle is quite a bit larger than 21 degrees and so on, but that's okay. Our drawing doesn't have to be exact unless you're trying to make a scale drawing, then it doesn't really matter. But finding out this information gives me some sense of what this picture actually should look like. Okay, let's see what else we've got here. Okay. Yeah, problems 8 and 10 are a little bit different, so let's take a look at those. So, problem 8. To estimate the height of a tree, one forester stands due west of the tree, and another forester stands due north of the tree. Well, let's see, I'll do a couple different drawings here. So here's one, forester 1, and here's forester 2. So this is due west, and this is due north. The two foresters are the same distance from the base of the tree, so I'll call those both X. And they are 45 feet from each other. Okay, so this is 45 feet. If the angle of elevation for each forester is 40 degrees, how tall is the tree? So what we've got there is a situation, let's see, here's the tree. Let's see, there's one forester, there's another forester with a right angle. We know that these are the same and that this is 45 feet. And then we've got these angles of elevation here and here, which are both 40 degrees. And what do we want to know? How tall is the tree? Well, what we need to do is find the value of X here. And then once we know X, we can say the tangent of 40 degrees is going to be H over X. Finding X shouldn't be too difficult because you can see that we've got a right triangle here, so that X squared plus X squared should be 45 squared. Let's see here, 45 squared. I don't know what that's going to be, 15,000 something? No, way up. 2,025. There we go. Okay, so divide that by 2. X squared is 1,012.5, and then we'll square root that. And so X is going to be approximately 31.82 feet. Okay, so that's good to know because now we can come over here and say tangent 40 is H over 31.82 feet. And so that means if we multiply on both sides by 31.82 and divide on both sides by the tangent of 40 degrees, those cancel, and what do we get here? Oh, that's not what I want to do. I'm making this way more complicated than it actually needs to be. Let's see, let's back up here. Tangent of 40 degrees is H over 31.82 feet. All I have to do is multiply on both sides by 31.82. Duh. There we go. So H is going to be this calculation right here. So again, I've got the full value of this 31.82. It's the square root of this number right here. Still got it on the calculator. I'll just go times tangent 40 degrees. 26.7. And there we go. So we didn't need to do that system of equations thing. We didn't need to make a substitution for this problem. So that was kind of nice. But it was not in a plane surface, right? We had one triangle in one plane, and then a second triangle was in the third dimension. Makes it a little bit trickier to visualize. I think that's probably why I included that problem in this section. Okay, let's look at problem 10. Problem 10 has some similarities to this, but I'm not sure. Let's take a look at it. So we've got fire station, lookout alpha. The bearing of a forest fire is 52 degrees east of north. Okay. So 52 degrees east of north is going to be in that direction right there, where that angle is 52 degrees. Okay. Lookout station beta, 6 miles due east of station alpha. the bearing is 38 degrees west of north. 38 degrees west of north is going to be something along those lines. How far is the fire from station Alpha? So, what we want to find is that distance right there. Okay. Let's see here. And we know that this right here is 38 degrees because it's 38 degrees, where are we? 38 degrees west of north. Okay, good. So, if this is 38 degrees, this whole thing right here is 90. So that means that this must be 52 degrees. And same thing over here. This one right here has got to be 38 degrees. That makes this a right angle. Okay. We know that this hypotenuse is 6 miles. So now we can say what? You know, we can choose any of the trigonometric functions really. I would use sine or cosine because we know the hypotenuse. So I'll use the 52 degree angle and say sine of 52 degrees is d over 6. And so d is just going to be 6 times the sine of 52 degrees. Let's find out what that is. 4.73. 4.73 miles. Okay. All right. Well, we got one more problem in this section, and then that'll be it for chapter 1, and then we'll start in with chapter 2 before the end of this week. Okay. Television tower, 75 feet tall, is installed on the top of a building. Okay, so there's the building, there's the tower. We'll make it something like that. Point on the ground in front of the building, the angle of elevation to the top of the tower is 62 degrees. So there's 62 degrees. And the angle of elevation to the bottom of the tower is 44 degrees. Let's see, I'll use a different colored pen there. So that angle in there, I believe it was, what, 44 degrees? Yeah. Okay, and we know that this distance right here, this distance right there, is 75 feet. We'll call the height of the building h. And let's see here. And we don't know how far, we don't know this distance right here. So it looks like in this one, I think we're going to have to make a system of equations and do a substitution. So let's take a look at it and see what we get. The big triangle, we've got the tangent of 62 degrees as being h plus 75 over x. And then in the small triangle, we've got the tangent of 44 degrees just being h over x. Okay, let's see here. What do we want to do? Well, let's get both the h's by themselves. It doesn't matter in this case. I'll do something similar to what I did last time. H is x tan 44 degrees. So we'll bring that over here and say tangent of 62 equals x times the tangent of 44 plus 75 divided by x. Multiply on both sides by x. And I get x times the tangent of 62 equals x times the tangent of 44 plus 75. Okay, so let's get some approximations. Tangent 62 degrees, 1.88, let's see here, 1.88 0.907x, and then tangent 44, 0.9657 x plus 75. So then we'll subtract this over to the other side. So 1.8807 minus 0.9657 gives us about 0.915x. Divide on both sides by 0.915. So 75 divided by 0.915, 81.97 approximately. And then we're going to take that and multiply it times the tangent of 44 degrees times tangent 44. About 79 feet. So H is going to be about 79 feet. A little bit taller than the TV tower itself. Okay. All right, so that's it for section 1.5. Like I said, this is the end of chapter 1. We'll come back to this kind of idea of solving triangles using both right triangles, and then, like what I'm saying is that at the end of the course we'll come back to this and look at solving things that are not right triangles. But for right now, we're just going to leave this here, and then we'll move on to chapter 2. As always, if you have any questions on this, please let me know. Thanks.